Hello, everybody. So this is the recording for week 9, lecture 1, which is going to cover loops, as you can see here. So this is zyBooks chapter 9. Also, there should be a link here to useful resources, free textbook. And if you click on that, then we should end up here, which should point you to a PDF download of a full textbook. So that full textbook is here, and says here that this is sections 3.3 and 3.4 in that textbook. So if you go there and we have, let's see, table of contents in our textbook, this is a PDF. And if you check chapter 3, you can find 3.3, which it says the while and do while statements. And 3.4 is the for statement, which is specifically, those are the two we're going over, which is while and for. All right. So you can find those in the textbook for more reading. We also have a set of lecture slides here. So I'll download the lecture slides. We'll pop them open. Looking down here, I don't see Eclipse. So I will also open Eclipse while we're doing that. And let us look at our slides. All right, so we have what, 15 slides here or so? And let's get going. So what a loop is, well, in this lecture, what we're going to learn is what is a loop, how to write and use while loops, and how to write and use for loops. So while loops and for loops. There are other kinds of loops. Actually, if you read that textbook, they talk about a loop called do while, but we don't really cover that because these two right here, while and for, cover essentially every use case that you would want. So we don't really need another kind of loop. These loops are fine. So what is a loop? So loops are programming constructs that allow you to repeat a set of instructions multiple times. They're essential for automating repetitive tasks and iterating over collections of data. For example, we've seen strings, right? Strings have a bunch of characters in them. Well, what if you needed to do something for every single character in a string? Like, how would you do that? Well, you'd do it with a loop. So you could loop through the characters in the string and do something to them. What? I don't know. What else? Okay, so Java provides two main types, while loops and for loops. So we cover both this week. So let's just jump in. A while loop repeatedly executes. So the whole point is that we're running a section of code multiple times. So we repeatedly execute a block of code as long as a specified condition remains true. So we have while condition, and then some code to be executed goes inside, and you enclose it in curly braces, just like you do in if statement. So the condition that you put here is going to be evaluated before executing the loop. And if it's false, we're not going to do it at all. But if it's true, we're going to do the code inside the loop. And then after we do the code inside the loop, we come back up to the top and we check the condition again. So as long as the specified condition remains true, we're going to keep looping and running that code. So I'll show you an example here. This is our last lab. I'm going to delete what's in here. So it's not lab 8, despite the name now. Let's do this. So if I do this, if, just make a really silly condition here, 3 less than 5, and then I do system.out.print line, and let's just say if was true. Now, we know that if statements, the way they work, if you do if 3 less than 5, which is true, it's going to execute this line of code, and it should just print that the if was true, right? Maybe I'll do this, if. Run. Compile. And there it goes. So it does it one time, right? If was true. Now, if I just take this exact same piece of code and I put it down here and I change it to while, it's going to keep running this code over and over and over as long as 3 is less than 5. But 3 is always less than 5, right? So if I run this code, you can see that it now says if was true, and it just keeps saying it. Now I should change this to say while so we could see the difference between these two. So let's do that and run it again. And you can see it's actually printing while was true. And if we scroll up, you can see that it was just doing it over and over and over forever. So that's what we call an infinite loop. It's a loop that starts looping and never stops. Generally, you don't want to make those. You want to make loops that do stop. So you could do something like this, for example. So if I say, let's say int, let's say x equals 1, and then I put the x here. Well, now x is 1 and 1 is less than 5, right? So if I run this, we're still going to get an infinite loop because 1 is always less than 5. So it runs, it keeps checking the condition every time, but it checks the condition, prints while was true, comes back up top, checks the condition, prints while was true, checks the condition, prints while was true, and so on over and over and over and over forever. If you want it to stop, you need this statement to become false somehow. So what if I just do this? X equals x plus 1. So now I'm going to add 1 to x every time through the loop. So when I run it now we just get it 1, 2, 3, 4 times, right? So just so we can see what's happening here, I'm going to add this. While it was true and x was, and then let's put the x in there so we can see it. So what happened was the first time through the loop, the while was true and the x value was 1. But then we added 1 to the x value, so it became 2. So you come back up to the top, while x less than 5 was 2 less than 5, which is true. So it printed the second statement while it was true and x was 2. Then we add 1 again, so now x is 3, back up top. While it was true and x was 3, add 1 to it to make it 4. 4 is less than 5, while it was true and x was 4, that's the last one. After it prints that out, x becomes 5. You come back up top and it says while x less than 5, which is 5, 5 less than 5. 5 is not less than 5, so that's false. So as soon as x becomes 5, this condition becomes false. If the condition is false, we're done with the while loop, and that's why our program finished. Now you can check it at the end if I do just one more printout of what the x value was at the very end. We should see that x was 5 at the end of the program, and it is. So we can run this code multiple times. So coming back here, you can see an example very similar to what we just did. I can set a count variable to 1. I can say while the count is less than or equal to 5, we're going to print it out, print out the count, and then add 1 to the count, right? So we should remember this plus plus notation for adding 1 to a variable. So count plus plus adds 1 to count. And if you run this code, it's just going to print count 1, count 2, count 3, count 4, count 5, and then it's going to stop. Because the last time this condition will be true is when the count is 5. Okay, when count becomes 6, then this condition would be false, and that's what stops the whole thing. So a while loop can be used to loop a specific number of times if you want it to. So like we made a loop here that looped 5 times. Over here, I made a loop that looped 4 times. Difference was this was less than, I could have made it less than or equal to 5, and then it would have gone 1 more, right? 1, 2, 3, 4, 5. And then it ends when x is 6. But we can count. But that's not really the main purpose of a while loop. This just explains the while loop that we have here. So in the example, we have a while loop that starts with the count set to 1, right? It's right here. The condition count less than 5 is evaluated before each iteration of the loop. If the condition is true, the code inside the loop's block is executed, which in this case prints the value of count using system.out.println. After executing the code inside the loop, the count plus plus statement increments the value of count by 1. Okay. The loop continues executing as long as the condition count less than or equal to 5 remains true. In each iteration, the count is printed starting from 1 and going up to 5. And then it says, note, it's important to ensure the loop's condition will eventually become false to avoid infinite loops. In this example, the count variable is incremented with each iteration. So the condition will eventually become false when the count exceeds 5, right? So that's what we did. Now, that's kind of it. You would when would you use these? Well, a lot of times you don't use them to count. So you normally would not use a for loop to count from 1 to 5, like we're kind of doing here. Normally you would use a while value when you don't know how many times the loop should execute. So sometimes what you do is this, for example. So like I could have a string and say like user input, for example. Maybe we'll just start it that way. And then you could do while the user input, let's say equals quit. And then I don't actually want when the user input equals quit, I want when they do not type quit. So I'll put an exclamation at the front, which we should remember that an exclamation point means not. So this is not user input equals quit. So that means loop while input is not quit. And then you can do whatever you want here. So I could just print something like the word input was, and then I'll just put the user input here, user input. And then after I do that, I'm going to ask the user for another word. So I'm going to go system.out.print, type in a new word. And then I could do user input equals scnr dot next to read one word from the user. So what is this going to do? Well, this is going to basically have me type in words until I type in quit. So when I run this, the first word, by the way, was nothing, right? Because I put nothing up here. And now it says type in a new word. And so I could say Greg. And it says the word input was Greg, type in a new word. So I could say yellow. The word input was yellow, type in a new word, right? And this is going to go forever, right? I can type Oreo. Why Oreo? Because I have a box of Oreos sitting right next to me. Type in a new word. What else is next to me? My glasses are next to me. Okay, I can keep doing this, right? And it's just going to go until I type quit, and then it stops. You can put a little message down here, system.out.println. Program is done. All right. Now, what can I do? I can say hello, food, blah, quit. And then it says program is done, right? So a good use of a while loop is to keep looping and doing something until the user is done. And you'll know the user is done when they type in the right thing in order to quit. That's a good use for a while loop, something that they get used for quite a bit. Now, one thing you may notice about this is that it's kind of a bit awkward the way this looks when you run it. Like it says the word input was, and there's a blank space, right? And that's because nobody typed in a word yet. Because they type in the word inside of the loop, but you type in a word after we print out the word because that's the way I typed it, right? So something that's not unusual to see is like in order to not have this happen, a blank word here, I could have just taken these two lines, the one that tells the user to type in a word and the one that reads in the word, and I could just repeat them in front of the loop. And if I do this, now when I run my code, it says to type in a new word. That's the first thing that happens. And I can type in some words. And now it kind of looks a little bit better, right? It doesn't print a blank word at the beginning. But in order to achieve that in a simple way without thinking too hard, what I had to do was I had to have the code up here that tells the user to type in a word and then it reads a word. I had to have it up here, and then I had to have the same two lines at the bottom of my loop. And that's one way to do it. And you'll see that code pattern being done a lot, like in the zyBooks, where they'll have this repeated code, one thing before the loop and one thing after or at the end of the loop. But it's the same thing. It's a weird thing, but it's the easiest way to make this look right. And so people do it fairly often. Having said that, I think we are done explaining what a while loop is. So we will move on to the next thing, which is a for loop. So a for loop is completely different in construction. So you have for, and then inside the parentheses this time, there's actually three sections separated by semicolons, semicolon, semicolon, right? So there's this first part, which they call the initialization, middle part, condition, last part, iteration. And what each of these three things is described right here. So the initialization is executed once before the loop starts. Okay, so whatever you type first happens one time. The condition, the one in the middle, is evaluated before each iteration, and if it's false, the loop is terminated. That's actually the same as a while loop. So the condition works the same as the condition in a while loop. And then the last one, the iteration, is executed at the end of each iteration, usually used to update the loop control variable. Okay, so this first one, initialization, happens once only before you start the loop. The last one happens every time you go through the loop, but it happens at the end. And the condition works exactly the same way that the condition works in a while loop. So what does that mean? Well, let's look at a while loop. So I'm coming back here. I'm going to just get rid of what we just did. And let's go back to a really simple thing. So let's say I do int I, and let's say I put in a 0, and then I make a while loop, and they say while x, nope, I, let's say less than 5. And what am I going to do? I'm going to print something out. System.out.print line. What are we printing? A word. What word? Cashew. Why? I have cashews. And then after we do that, I'm going to do I++ to add 1 to the I value. And now when I do this, it should print the word cashew 5 times. And then it says program is done. So cashew, 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 program is done. Okay. But if you think about this, this is what we just talked about a couple minutes ago about how to make a while loop count, right? We saw this right back here. where you can set this counter to a number. We check how big it is, compare it to another number, and you have to make sure that you do something like add to it. That way, eventually the condition will become false and the loop will stop eventually, right? So the thing is that if you look at this right here, this happened one time, right? Happens once before the loop, right? Because it's not part of the loop. And then the condition, move this way over. The condition is checked every time through the loop. And then way down here, we're going to add 1 to I so that the counter goes up, right? And if you think about it, those are the same things that were described in the for loop, right? Like this sort of thing, I equals 0, that could be the initialization. It's something that happens once before the loop starts. The I plus plus, that's something that needs to happen at the end of the loop. That way your counter is going to continue to count up. So that could be the iteration. And the condition, I less than 5, well, that could still be the condition. So the loop that we've got right here, we could do the exact same loop this way with a for loop. I'll use a different variable though. I'll use j. So I could say int j equals 0, just like I did int I equals 0 up here. And then the condition I less than 5 could be j less than 5, semicolon. Notice the semicolons there. And then the last thing in our while loop here was an I plus plus to add 1 to I. That could just be j plus plus. And then in here, I could just do the equivalent of this. I don't want to print out cashew because then we won't be able to tell which one's which. Almond. Run. So now we've got cashew 5 times and we have almond 5 times, and then the program is done. So you can see that basically what I have here on lines 11, 9, 10, 11, 8, 9, 10, 11, 12, and what I have here on 14, 15, 16 are loops that are doing the exact same thing in the exact same way. The only difference is that this j equals 0 is done right here in the for loop line instead of before the for loop line. And this j plus plus is done inside the for loop line instead of being done in the for loop at the end, right? So this right here, I equals 0 and I plus plus, those could be moved inside of the first line if you use a for loop instead of a while loop. Otherwise, we can do the same thing with both types of loops. So that is a for loop. Now, because of this structure here, where you can set a variable in the first section, put the condition in the second section, and then add to the counter in the third section here, that's really convenient that you can see kind of the loop starts at 0. The loop goes while j is less than 5, and we're adding 1 every time through the loop. You can just read that all in one line instead of like the top loop where I have to see the I on this line, and then I have to see the I on this line, and then I have to see the I on this line. 3 different lines. So that's the advantage of a for loop, is that it kind of puts everything in one line, and that is convenient. So here's an example of that same count loop. Int I equals 1, I less than or equal to 5, I plus plus, and then we just print out the count. So it's just a more concise way of doing the same thing. Now, something you may wonder is this int I here. Like, do you have to say int? No, it's a valid line of code. So there was no variable called j, right? If there was, like I can go up here, I can go int j, just make the variable exist up here. And then down here, I could delete the I and T, and we can just say J equals 0. So you're not always going to have it say int J or int I. You might just have J equals 0, I equals 0, something like that. Another thing is that there's another way to add 1 to a variable where instead of writing J++, you can write plus plus J. And for this purpose, those are identical. In general, they do slightly different things, but in this purpose, everything's the same. So you would see no difference in the code when you run it. All right, so that's a for loop. This explains the for loop. So these loop control statements can be used to control the flow of loops. Java provides other things. So you can use break, continue, and return. We don't really need to worry about these for the time being, but they can do things in your loop. Like, for example, let's change this for loop to put a 10 here. So this is going to print almond 10 times now, right? We can count 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 almonds. When we start at 0 and we go less than 10, we get it 10 times. But if I did something like this, I just type a break here, which we've seen before in terms of switch statements, and I run it now. Well, now it just did it once because the break statement will actually stop the loop from happening. So you can stop the loop early using break. You can use continue, but it's a little bit weird here. Let me take this cashew and put it in here. I'm going to delete this entire loop. So we just have one loop now. So this loop just prints now cashew almond, right? And so it does that 10 times. So we get a bunch of cashew almonds. Um, if I do break after the cashew, it's going to print. Do we have an error? Why do we have an error? Unreachable code. Well, okay, well, it won't let me do that. It wants me to delete this almond line because the almond line will never run. But that's annoying. Like, what would have happened if we didn't have this error here is that it would have print cashew and then it would have break and then you'll never print almond at all. But it won't let me do that because it's just decided not to. This is going to be the same error. What this would do if it would run is that it would print cashew and then continue. Continue would not stop the entire loop. Continue would go back up to the top and do the next iteration um, without printing the almond. And it just doesn't want us to write code that you can't actually run. We could probably fix it. We can cheat. Maybe we can do like if true. I don't know if this is going to work. Well, let me do that. So this is dumb, but if it lets me, we'll try it. Um, so if true means that's always going to run, right? So it prints cashew and then break. Break stops the entire loop from running. So then you just get program is done and never prints almond. However, if I do continue, now it's going to print cashew, then continue. Continue will not send it down to the bottom. Continue will send it back up to the top to do the next iteration. So we're going to get a bunch of cashews, no almonds, because uh, it never gets to this line because it's going to print cashew and then continue, which sends it back up top, cashew continue, back up top, cashew continue, until eventually the loop is done. And so it never manages to print almond. And so that's what continue would do. And return, you normally do not return from your main method, but what return does is it actually just stops the entire method that you're in. So if I run this, it says cashew, and then we returned, which finished the entire program. So now we didn't even get to print the program is done this time because we just stopped the entire program right here at the return line. So we don't really need to worry about these things at the moment. We don't have a use for them, but there are these things called break and continue and return that can kind of change the way that your loop works. All right, and then this just does what we said. So break statement terminates a loop prematurely. Continue statement skips the current iteration of the loop and moves to the next one. We saw that. There you go. So that is loops. Now, what we could do for maybe 10 more minutes is we can take a look at the week 9 homework, maybe, and we can look at some loops. Now, this will take a little while to do some of them. So while loops, they're going to explain it all. I'm not going to go through the participation activities, but we'll try to get to some challenge activities here. Here we go. Here's one. So we have to think about what's happening. Int g equals 0. Cool. While g is less than 3, which it is, right? 0. So you need to keep track of the g so you can compare it to 3. So g is less than 0. So system.out print g, which is going to print 0. It's not print line. So actually, we do not go down to the next line. It's just 0. And then g is g plus 1. So that's going to count up. So g started out 0. G is going to turn into 1. Then you come back up to the top of the loop, and you do 1 less than or equal to 3. Is 1 less than or equal to 3? Yes. So it's going to print it out, print out the 1. Then we add 1 again, so g is going to be 2. Back up top. Is 2 less than or equal to 3? Sure. So it's going to print it out. Add 1 to get to 3. Back up top. Is 3 less than or equal to 3? Yes. Right? Because the equal, 3 is less than or equal to 3. So we print it out. I already wrote it. Then we add 1. So g is 4. Come back up top. Is 4 less than or equal to 3? No. So we're done. We do not go inside of the loop. So this is going to print 0, 1, 2, 3. Okay. So there's 5 of these. Let's skip to the third. All right. Now they're counting down, right? We don't have to count up. We can count down. So same idea. G is 0. While g is greater than or equal to -2. It is. 0 is greater than -2. So that's true. So we print out g. So we're printing out 0. And then g equals g minus 1. So we're subtracting 1. So we're going down to -1, right? 0 minus 1, -1. Then we come back up here. Is -1 greater than or equal to -2? Yes. So we print out -1. So that's going to look weird when you print it, right? It's going to look like that. Then we come down here, g equals g minus 1. So we're subtracting 1 again. We're at -2. Back up top. Is -2 greater than or equal to -2? Yes, it's equal. So we print out -2 minus 2. Then g equals g minus 1. So we're going to go down to -3. Back up top. Is -3 greater than or equal to -2? No. So we're done. So it prints this. 0 minus 1 minus 2. All right, let's check number 5. This looks very similar to the other one we did, but it's fine. G is 3, so we're starting at 3 this time. Is 3 less than or equal to 5? Yes. Print G, so we get 3. Add 1, so we're at 4. 4 less than or equal to 5? True. So it prints the 4. Add 1, so we're 5. Back up top. 5 less than or equal to 5? True. So we print out 5. G equals G plus 1, so G comes up to 6. Back up top. Is 6 less than or equal to 5? No, so we're done. So this prints 3, 4, 5. The point is, you don't have to start at 0 or 1, right? You can start counting wherever you want. All right. So they're going to make us write some loops here. So let's hit start. Most of these are going to be like when you were writing if statements, where we're just writing what it says. So a while loop reads integers from input into the variable inval. So this is what I was talking about when I said that, remember when I was here and I said way back when we had a while loop. Oh, it was so long ago. Ah, I might have done it too much. I wasn't paying attention. Yeah, I wasn't paying attention, unfortunately. There we go. Way back here at this point, how I said that you could have like the 2 lines that tell you to type in something and then we read it from the input. Those same 2 lines might appear in front of the loop, above the loop, to do the exact same thing before the loop started. That's just kind of one extra input to get you into the loop in the first place. And I said that they do that in zyBooks, and this is an example. So you can see that they've got this line here that says inval equals scnr dot next int. And then at the end of the while loop, they also have inval equals scnr dot next int. So they're reading a number before the loop and also every time inside the loop, and that's perfectly normal. All right, that's not what we need to pay attention to. It says a while loop reads integers from input into the variable inval. Okay, write an expression that executes the while loop, and it says while a non-negative integer is read. So the number being read is inside of the variable inval, and we want it to be non-negative. So that just means it should be greater than or equal to 0. So check that to see if it's greater than or equal to 0. That's it. So they just wanted you to check if it's non-negative. Let's jump to the third. We got something a little bit more complicated in here, but I'm sure we can manage it. So it says integer value in is read from input. There it is. Write a while loop that iterates while value in is non-negative. Okay, cool. So we just remember that, right? While, in this case, it's called value in non-negative. That means greater than or equal to 0. Cool. Now, what is it supposed to do? In each iteration, update integer final val as follows. If value in is not divisible by 5, okay, so we have to remember how to check if something is divisible by 5. They actually remind you right here. So this modulo operator is the remainder when you divide. And the remainder is 0. That means that the number went in evenly. So when you do x mod 5, x modulo 5, you're dividing by 5 and you get the remainder. When the remainder is 0, like it shows here, that means that the number is divisible by 5. So it says if value in is not divisible by 5. So if I did this, nope, not that. I was trying to copy this. This right here would be if it is divisible by 5. So if I want not divisible by 5, instead of equals, I could use not equals, right? Remember, we learned those for if statements. So the remainder when you divide by 5 is not equal to 0. That means not divisible by 5. So if not divisible by 5, output when. So we got to do system dot out dot print line when, and then it says and increment final val. Increment means just add 1. So final val plus plus. That will increment final val. And then it says otherwise, we know that that's an else. So we'll go to the end of our if statement and write else. Output lose. Okay. Lose. And do not update final val. So we just do that. And then after that, it says then, so this right here is describing that if statement that we just wrote, which we just finished. This right here is not inside of the if statement, but it needs to be inside of the while loop. It says then read the next integer from input into variable value in. And so the point is that this loop would be an infinite loop, right? Unless you read more integers. So you're reading the integer once before the loop starts, and then once at the end of your loop. And oops, not save. And that's exactly what happens here, right? I read the word before the loop, and then I read the word inside the loop. That way I get a new word to read. So you read the integer before the loop, and you read the integer inside the loop. That way you have a new integer to read. Okay, so we did what the instructions said, and this should just work. What'd we do? All right, it's got to be some typo. Let's see. Oh, right, I didn't pay attention. So we copy pasted this x modulo 5, and that is true if x is divisible by 5, but x was the wrong variable, right? So we're supposed to be doing if value in is not divisible by 5. So here I wrote an x, but it needs to be value in modulo 5. So we copy pasted it, but we didn't change the variable to our variable. All right. And there we go. And they checked this little game. I think they're just keeping track of how many times you win. And you win whenever you type in a positive number. No, you win if you type in a number that is not divisible by 5. So if you type in 3 numbers like this, then 6 wins because it's not divisible by 5, but 10 and 15 lose because they are divisible by 5. So that's why you get win, lose, lose. And every time you win, you add 1 to your basically your total wins. So we won 1 time. If you type in all these numbers, they're all losers because they're all divisible by 5. So you never won, so your score is 0. If you do this, you win a bunch of times because none of these are divisible by 5. And that's 1, 2, 3, 4, 5, 6. So we won 6 times. And you'll notice that they always end with a negative number here. And that's because, this one didn't end with a negative number. What? Oh, okay. Well, this number was extra, I guess. So as soon as you type in a negative number, that's telling you that you're done with the game. Not that it's a very good game. So like here, the negative is here. So we did this 3 times, and you see the 3 results. Here we did this 1, 2, 3, 4, 5, 6 times, and then the negative ones finished the game. Here we did it 1 time, right? The negative is here. So the 0 was the 1 time we played and we lost. then the negative one finished the whole thing. And then this one is just like an extra number on the end that's not doing anything. Okay. All right. So I believe what I want to do is let's just do a little bit more while examples. Um, so this is a program that's going to be calculating the greatest common divisor of two numbers. So it's like the biggest number that goes into them. So it's like 9 and 7 have nothing in common. And so the GCD is 1. But a 15 and a 10, they like the biggest number that goes into both of them is 5, right? 5 goes into 15 and 5 goes into 10. So the GCD is 5. Enter the first positive integer 99, enter the second positive integer 33. Well, the biggest number that goes into both of them is 33. The biggest number that goes into 500 and 500 is 500. So they wrote this program that does this, and it does a calculation called Euclid's algorithm, which is not like really the point of the lecture, I guess, but they type in two numbers, and Euclid's algorithm is done with a while loop. And so they don't actually, they didn't actually write Euclid's algorithm in a good way of looking at it, but this did use a while loop, so they printed it out. We can go through like one or two of these here. For the GCD program above, what is the value of num_a before the first loop? So we have these here. Now, what you might want to do if you are trying to like actually think your way through these is get, oh, this is Eclipse. I don't really want Eclipse. I want Visual Studio. So this is a program, some work I was doing earlier. Put this in. So I'll try to do this. Hopefully this will be legible. That can go away. Where's my web browser? There it is. All right. So we can try to work through this. So we're starting this out with so many things in the way. Num_a is 15 and num_b is 10. That's what it says right here. And then it says for the GCD program, what is the value of num_a before the first loop iteration? So, you know, we're reading these numbers in, num_a and num_b, and it says before the first loop iteration. So if we haven't done anything yet, then it says, what's num_a? Well, num_a is going to be 15, right? That's what it's starting out as. Okay. And then it says, what is the value of num_b after the first iteration? Okay, so we got to figure out what happens after we go through this one time. So we've got num_a is 15 and num_b is 10. All right. So it says while num_a not equal num_b, well, they're not equal. So we do go inside the loop. And then it says if num_b greater than num_a, num_b greater than num_a. No, it's not. Right? So this is false. This condition's false. So we're not going to do this branch. We're going to do the else, right? So num_a is going to be num_a minus num_b. So if we take 15 and we subtract 10, we're going to get 5, right? So what's going to happen is num_a is going to become 5 because it's going to be 15 minus 10. And we didn't do anything to num_b, I don't see, so I guess it's still 10. So that's what happens after one iteration of the loop is we're here. So it says, what is the value of num_b after the first iteration of the while loop? It is 10. Then it says, what is num_b after the second iteration of the while loop? Okay, so let's go do the loop again. So the while loop, num_a not equal num_b, right? That's true, they're not equal. So we come inside the while loop. And then it says if num_b greater than num_a, num_b 10 greater than num A 5? It is. Okay, so this time num B is greater than num A. So because num B is greater than num A, we're going to run this line. So this does num B equals num B minus num A. So num A is not changing, so it's still going to be 5. And then num B is num B minus num A. So it's going to do 10 minus 5. 10 minus 5 is 5. So we're going to get num B equals 5. So the question was, what is num B after the second iteration of the while loop? And looks like it's 5. And they explain it too. How many loop iterations will the algorithm execute? Well, we've done 2 so far, right? And after that, you come back up to the while, and it says while num A not equal to num B, they are equal. So this is now false. So we're actually done. So we did 2 iterations of the loop, and we are done now. So 2. All right. So we did it. So we can read this, I guess, if we want to. I'm trying to look for, well, we can do this. We can try to think our way through it. What does this do? This is just an example to try to think through. Below is a program that has a conversation with the user, asking the user to type something and then randomly printing 1 or 4 responses until the user types goodbye. So you see how it says until the user types goodbye, and then you'll see this while loop while user text equals goodbye with a not in front. So not goodbye, basically. So when they type goodbye, that makes the loop stop. Okay. The program uses next line to read a string. Sure, that's how you read something from the user. The loop checks whether they said goodbye. If not, the loop executes. The loop body generates a random number between 0 and 3. They have random here in quotes because they are not generating a random number. So that's why they have it in quotes. What they're doing is they're taking the length of the string. So like, if your string is 17 letters, it's doing 17 divided by 4, and the remainder would be 1. So you're going to get 1. If the user typed in, 23 letters, it would do 23 divided by 4 and get the remainder, which would be 3, and so on, right? So they're getting a number between 0 and 3 this way. But it's not actually random. It's just based on how many letters they typed. So it's not a random number, but it's how many letters they typed. And then if that random number is a 0, they say, please explain further. If they have a 1 for the random number, they say, why do you say that? If they say 2, or if it comes up 2, they say, I don't think that's right. And they say, what else can you share? Else it says something went wrong. So that should never happen. That should never happen. You should never end up in the else. And there you go. So we can actually see what this does when you run it. It'd probably be kind of funny to run. So I've copy pasted everything here. We're going to go to Eclipse, and I'm going to delete the inside of main, but nothing else, and paste it all just so we can run this. So it says, tell me something about yourself. I wet the bed. It's my psychologist here. I don't think that's right. No, it true. I don't think that's right. Why? Okay, well, I need to type more letters or something. Why? 1, 2, 3, 4. What else can you share? I don't. So they're not random numbers, and so I just, based on how long my text was, I got the same thing 3 times. What else can you share? I am 3 foot 2 inches tall. Why do you say I am 3 foot 2 inches tall? I don't know. Please explain further. No. What else can you share? Nothing. Goodbye. It was nice talking to you. Goodbye. Okay. So kind of a funny little program. But you see that the while loop can make this go as long as we want, and you only have to type goodbye when you want it to stop, which they should have told you to type goodbye when you want it to stop, but you're not, they didn't really intend for you to run this. So here's an example of it running. Cool. So they say, what will be printed if the user types ouch? So remember that the random number is how many letters there are. So you count the letters, 1, 2, 3, 4. Then you divide it by 4 and get the remainder. So 4 divided by 4, 4 goes into 4 one time with remainder 0. So the remainder is 0. So if you type ouch, the remainder is 0. So it should say, please explain further is what it should say. What will happen if you type by? Well, that's 3 letters. So when you divide by 4, the remainder will be 3. So it should print number 3, which is what else can you share? Which branch will execute if the user types goodbye? If they type goodbye, then the answer is none, right? That's what ends the entire program. How many loop iterations will execute if the user plans to type, I'm hungry, you are weird, goodbye, and I like you? So that's 4 different things. But remember that goodbye is actually the one that is going to end the loop. So I'm hungry is 1 loop iteration. You are weird is a second loop iteration. Goodbye, I would not count goodbye as a loop iteration. Goodbye is going to end the whole thing. So I would say 2. All right. Now it says getting input until a sentinel is seen. A sentinel is just like a number that you're looking for or a value that you're looking for. So like goodbye was the sentinel here, right? It's the thing you're looking for to stop the whole thing from going on. So when it says like computing the average of a list of numbers, and it says while current value greater than 0, right? So you have to type in numbers greater than 0 to keep going. That means when you type in 0 or something smaller than 0, your loop stops. And so the stopping value there is 0 or a negative number. And so that's a sentinel. They intend it to be 0. So when you type 0, that's how it knows to stop, right? That way you can do an average of 1, 2, 3, 4 numbers, or you can do an average of 1, 2, 3, 4, 5, 6 numbers with the same code, right? You don't have to know how many numbers you want to average because you can just type in all your numbers, and when you're done, you type 0. So you can do average 3 numbers, you could average 300 numbers, doesn't matter. So that's nice code. How many non-sentinel values are given for the first input sequence? Do they mean this? 1, 2, 3, 4, I guess. For the first input sequence, what is the final value of num values? I mean, I assume that they're going to add 1 every time we get one of these, so probably 4. I'm not going to read the code. Suppose the first input was 0. Would values sum over num values be 0? Um, I don't know. When you divide, you can't divide by 0 or you get a negative number or you get infinity. And if you divide 0 by 0, you get not a number. Um, Yeah, divided by 0 is an error. You actually get not a number if you divide by 0. What would happen if this list input was 10, 1, 6, 3? -1 is what will stop it. So the other four numbers should be averaged, which we didn't really look at the code, but let's say that the average works. So 10 plus 1 is 11, plus 6 is 17, plus 3 is 20, and then 20 divided by 4 is 5. So the real average is 5. So assuming this program does what it says it does, I guess the output would be 5. Right? The negative will stop it. Okay. So same thing here. This is actually, they're going to find the biggest value that you type. And they're going to do that by keeping track of the biggest number that you've typed in so far. So if you type in 2, 34, 12, 0, 0 is the thing that will stop the while loop, right? Because it says while entered value greater than 0. So 0 will stop it. So the other numbers there, 2, 34, 12, it's going to keep track of the biggest number it's seen, which is 34. So this is the same thing, except it's a minimum value. They don't even say that, but if you kind of trace through what's happening here, what happens is it says entered value SCNR next int. So let's just say you get 44, right? So you have entered, I'm just going to say, well, I can type it, entered value equals, the first number typed in is 44, right? And then it does min number equals the entered value. So min number equals the entered value, which is 44. So we'll just keep track. While entered value greater than 0, it is. If entered value less than min number, it isn't. Min value equals entered value, but that was false, so we're not doing that. So the next thing it does is it does entered value equals SCNR next int. So it reads the next number into entered value. So SCNR next int is going to read the 23 into entered value. So I come back up here, place that with a 23. Now, after you do that, you're back up to the top of the loop. While entered value greater than 0, it's 23. And then it says, if entered value, 23, less than min number, which is 44, so the entered value is less than the min number, then min number equals entered value. So that's going to change the min number to be equal to the entered value. So we're going to end up with 23 and 23. Then we do this line, entered value equals SCNR next int. So it's going to read the next number, which is 56. So 56 will be the entered value. After we read the 56, we come back up top. While entered value greater than 0, it's 56. If entered value 56 less than min number, it is not. So we're not going to run the next line. We just go down to entered value equals SCNR next int. It's going to read 12. So we'll replace the entered value with 12. Back up top, while entered value greater than 0, it is. If entered value less than min number, entered value is 12, min number is 23. So 12 is less than 23, so we're going to go down to the next line. Min number equals entered value. So we're going to replace the 23 with the 12. And then we read one more value, which is 0. So the entered value is going to be 0. Back up top, and it says while entered value greater than 0, which it is not, so we're done. So we're done with the whole while loop. We come down here, and it says system.outprint min value equals, and it prints the min number, which is 12. So what this does in this while loop is this if statement is any time we see a number smaller than the min number, we replace the min number with that number. So what it's doing is as it looks over a list of numbers, it's keeping track of the smallest number that it has seen so far. So when we see the 44, the smallest number is the 44. But when we see the 23, uh-oh, that's a new smallest number. So now the smallest number is 23. It looks at the 56, but the 56 is not smaller than 23. So we keep 23 as the smallest number we've seen. And then we see the 12, and 12 is smaller. So we replace the minimum with 12. So we're just keeping track of the minimum number we've seen out of all the numbers we've seen so far. So we end up with 12 there. Wait, what? Oh, dang it. I didn't copy paste the words. I only put the number. I'm stupid. All right. Now, this one is the same thing. This is the same code, but with these numbers. And once you understand that what it's going to do is keep track of the smallest number that it's seen so far and that 0 stops it, you really just have to look at these and say, not that. You should say, what is the smallest number off the list? And it's 2. So it's going to print 2, but it's going to print min value colon space 2. Right? So I didn't type min value last time. That's the only reason we got it wrong. All right, let's do this one. So I don't know what this one does, right? The last one was called min value. We were able to figure it out what it does. This one, who knows? So there's still an entered value. And now instead of min number, there's a thing called final product. And let's get rid of the numbers and let's see what's going to happen here. Right? So our numbers are 7, 2, 5, 7, 2, whatever, 7, 2, -5. So looking at it, final product is 1. Okay, so you come here, put a 1. Entered value equals SCNR next int. Reads a 7. 7. While entered value greater than 0, it's 7. Final product equals final product times entered value. So we multiply these two things together, 7 times 1, and it puts the result in final product. So 7 times 1 is 7, and then we replace the final product with that. Okay. Then we go back to entered value. Entered value equals SCNR next int, so it reads a 2. So replace entered value with 2. Back up top, while entered value greater than 0, so 2 is greater than 0, final product equals final product times entered value. So we multiply these. 2 times 7, 14. We take that product, 14, and we put it back in final product. So we replace the final product with 14. After we do that, we read a new entered value. Entered value is next int, which is -5. So we replace the entered value with -5. Then back up top to the while loop. While entered value greater than 0, it's negative, so that's false. So we're now done with the while loop. After we're done with the while loop, it prints product colon space and final product, which is 14. Right. So when you're doing these, you kind of want to kind of keep track like this. You can do it on paper, that's fine. Or, you can use, just a text editor just to keep track of variables. And then you will make fewer errors in that case. So, I mean, we can do this. 1, 2, how many more do we have? Actually, let's say we're gonna jump down and do something else here. Let's jump down all the way to here. 9.3.4. So 9.3.4 here. let's read it. We don't need the text editor now. Wait, or 4 or 5? Well, I said 4, so let's do 4. Let's see, what's it say? Use SC&R nextInt to read the remaining integers from input into input data while input data is not 99. So I see while input data is not 99. So let's go here and let's go input data not 99. So that is, oops, not equal 99. Okay. For each integer read before 99, right? Because 99 stops it. If the integer is positive, okay, so we need to go in our loop. If the integer, which is input data, is positive, which is greater than 0, something, what? Let's see. If the integer is positive, output the integer followed by a new line. Okay, so we need to output the integer. System.out.println input data. So output the integer followed by a new line and add the integer to total of selected. So we need to add it to this. So that would be total of selected equals total of selected plus input data. Or the shorthand way of doing that would be plus equals, input data. So this would add input data to total of selected. Okay, now if you ran this, you're going to get an infinite loop and they'll probably tell us about it. So I'm just going to let it do its thing. It's going to tell me about the problem, I'm sure, and then we'll fix it. Taking a while. So it's probably taking a while because of that infinite loop. It probably lets it run a certain length of time. And you'll say program generated too much output, restricted to 5,000 characters, check program for unterminated loops. Okay, so this is where I want to take you back to an earlier example and remind you that in almost all the loops that we've seen, they were reading something before the loop started, like in this case, current value, I just scrolled up to 1. And at the end of the loop, you'll see the same exact line where they read the next value. And that was true for the other examples that we've done as well. And like here, right? Current age. We didn't do this one, but we did the other two. Like they still read something before the loop and then did the same thing inside the loop. And so I purposefully left that off here to kind of make that point that they're reading this number. And that's only the first one that's read. All the others have to be done inside the loop. So kind of after this if statement here, but still inside the while loop, you need to read the next number. Otherwise, we're not reading numbers, right? So every time through the loop, you need to read a new number. So you should get used to this. Read a number before the loop, read a number inside the loop at the end. And then that fixes our code. All right, let's do a different one. Advanced while loop examples. Uh-oh. String input word is read from input. Okay. Write a loop that iterates while input word is not equal to pigeons. Okay. Hit start. So input word dot equals pigeons. So this is how you would check if input word equals pigeons. If you want not equals pigeons, then you would just go to the beginning and put a not, which is an exclamation point in front of it. So this would be not equals pigeons. In each iteration of the loop, output still waiting for pigeons. This is a really good program. I like it. System dot out dot print line, still waiting for pigeons. Read string input word from input. So again, this is where you have to look above the while loop, copy paste one like that, reading a word in, and make sure you do that inside your loop, right? To give them another chance to type pigeons. And that should just be it. Should work fine. Or we need to read more closely, one of the two. Nope, it was good. Let's skip to the third one. The most advanced of while loops, maybe. Let's see. The first and second integers in the input are read into variables, previous data and current data. There is where they do that. Write a loop. Uh-oh, we got to write the entire loop. Wow. Okay. Write a loop that iterates while current data is greater than or equal to previous data. Okay, that's not hard to understand, right? While, and it just literally says current data is greater than or equal to previous data. Hardest part is spelling the word previous. Then we do something. Cool. What do we do? In each iteration, so inside the while loop, output current data followed by is greater than or equal to previous data and sequence is not decreasing. Okay, so that's a lot of printing. We could do it all in one line, or we could split it up into separate print statements. I'm just going to put everything in one line because I'm lazy. System.out print line. What are we doing? Output current data. Boom. Plus. Followed by is greater than or equal to. I missed the first quote there, so I'll have to remember to type that. Quote, paste. Is greater than or equal to previous data plus previous data plus sequence is not decreasing. Sequence is not decreasing. So that's a really long line there. If you don't like typing it that way, we don't have to do it all in one line. Like I could do a system.out print, and I could print current data is less than or equal to previous data like that, and then just kind of end it right there, and then come down to the next line and then do a system.out print line, and then just print this sequence is not decreasing. That way, it'll all end up on the same line, right? Because this is not a print line, it's just a print. But, that way we can keep it all on the same page here. After we do that, it says assign previous data with current data. So that's just literally previous data equals current data. Read the next integer from input and assign current data with the integer read. So we need to read a number into current data. So I can just copy paste the line that did that previously. And we'll just put that down there. Ooh, kind of indented weird. Let's put it there. Oh, after the loop, we got more. We have more. After the loop, output the last integer read followed by breaks the sequence. Okay, we need another system.out print line, and it is the last integer read. Well, the last one we read is in, I think, this variable current data, right? And followed by breaks the sequence. Breaks the sequence. All right. So this has been a long lecture, but I think the examples are useful. So that's why I let it go on so long. But this has been a little bit too long, so we're going to stop here. We're going to do the for loop examples in the next lecture, okay? So we will stop and I will talk to you guys later.